Bismillahirrahmanirrahim. So last week we finished our slides on this topic. So just to remind you that what we were doing the HTTP and the web. So specifically programming of HTTP and web in the Python programming. So HTTP method. So when we use the HTTP method, so we have been using the request in the previous class. So asking server to send, the web resources. I'm just doing a recap. I believe I did this one in a little bit in the lab, but we are just reviewing it again so that we can finish this topic. So, but HTTP provides more action that we can perform. So get in our request line is an HTTP method. And there are several methods such as head, post, option, put, delete, trace, connect, and patch. So we will be looking at several of these in some of the details in the coming chapters. So head method is the same as the get method. So the only difference is that the server will never include a body in the response. So suppose if we send a request to the the web server from using the head method, we will only get a response, but not the body of the the file or the complete response. So there is a valid resource request URL. The head method is used for checking if the resource exists and it has not changed, or if it is changed. So note that some servers don't implement this method, but when they do, it can provide a huge bandwidth saver, right? So instead of sending the wrong website, they will just give you the information, and you can, using your Python programming, you can communicate and get some specific parts as we did in the request method. So here we, just looking at this example, we are sending a request as a, the Google, HTTP, the web address of the Google, and using the method head. So the response will be stored using the URL open method and in the required. So the response status is okay, and response read will tell you the. So here server has written okay, and the body is empty, nothing. As we mentioned that head does not respond. So post method is in some sense the opposite of the get method. We use the post method for sending data to the server. However, in return, the server can still send some full response. So post method is used for submitting users input from the HTML forms and uploading the file to the server. So like suppose if you are filling some forms, so you can use the post method. I just remind you that these methods are for the URL. So sending something using the URL, okay? So when using post, the data that we wish to send will go to the body of the request. So we can put any bytes data in there and declare its type by adding a content type header to our request and with an appropriate MIME type. So let's look at an example for sending HTML from data to server by using post request. So just as behavior browsers do when they submit the form to the website, the data always consists of key value pair, and URL lib, the package we are using for the Python lets us to work with regular dictionaries for supplying this. So we will look at where this comes and following action. So we provide the data underscore dict, and we provide P is for the Python. So when posting HTML form data, the form value must be formatted in the same way as query string are formatted in the URL. So and must be URL encoded, right? So a content type header must also be sent to a special MIME type of application, the slash x dot www dash form dash URL encoded. So what does it means that query strings? So like suppose when we write, we can leave the gap, we put the space between the the sentence and the words. So but in the URL no space required, so we have to use special strings, okay, query string. So since this form is identical to the query string, we can just use the URL encode function of our dict for preparing the data. So data is equal to URL encode underscore data encode, dict, and encode UTF-8. So we defined the encoding scheme. So that we also additionally encode the result to bytes as it's to be sent as the body of the request. In this example, we use the UTF-8 character set. So next we will construct our request. So now you see the request is search Debian org/omega data is equal to the data. So by adding our data as a data keyword argument, we are telling URL lib that we want our data to be sent as a body of the request. So this will make the request use post method rather than get method. So next we add the content type header. So req.add underscore header. So content type and application URL and set. So lastly, we submit the request for the URL open. So if we save the response data to a file and open it in the web browser, then we should see some Debian website search result related to Python. So in the previous section, we used URL. Now we are doing a formal inspection. So we did a URL search.debian.org, CGI bin, omega, and dictionary type. We used the Python, but we did these come from, where they come from. So we get these by visiting the web page containing the form we would submit to get as a result manually. So we then inspect the HTML source code and web page. If we are carrying out the aforementioned search in the web browser, then we would most likely to be in the the http.org page. So we would be running a search by typing search type into the search box. So suppose we are opening the page of the Debian and there is on the search bar on the top. So we are writing our query on the search bar. So most modern browsers allow the dictionary inspect the source for the element on a page. So to do this, right click on the element, which in the case is search box, then select the inspect element option. So you might have done this practice. So you will see like this. You see this is the search box here. So what we did, we did a right click. So right click will show you the this appearing, and the bottom you will find inspect element. When you press inspect element, you will see this bottom window. And I assume that I think almost every one of you have done this sometimes, checking the browser and you press this and you inspect element. So the source code will pop up in the section of the window in the preceding screenshot, and it's at the bottom of left corner screen. Here you will see some lines of the course look like the following example, like form, action, HTTP search, Debian omega, method get, name p, input type, hidden value, name db, the input size, name, and all this. So you should see the second input highlighted. This is the tag character that corresponds to the search text box. So the value of the name attribute of the highlighted input tag is the key that we use in our data underscore dict. So which of this in case is P? So we provided P as a name. You remember for the Python, we provided P. So we created a dict using P colon is equal to Python. If you remember this, our previous input here, we provided data underscore dict is equal to Python in single quote colon, sorry, P in single quote colon Python. So that's how we provided the name. Okay, so then the value of our data dict is that we want to search for. So to get URL, we need to look above highlighted input for the encoding form tag. So here our URL will be of the value of the action that attributes. So that is, the omega, this whole URL. So the source code for this page is included in the source code download from this book in case the Debian changes. So you can see this source code, but sometimes the web pages are updated, changed, so you got some different result. So this process can be applied to most HTML pages. To do this, look for the input corresponding to the input text box, then find the URL form, and enclosing the form tag. If you are not familiar with HTML, then in this case you will be a bit of trial and error process. We will be looking at some of more methods parsing HTML in the next chapter. So once we have our input name and URL, we can construct and submit the post request as shown in the previous section. So we just saw in the brief. So now we are going to move HTTPS, and before I move, I have two questions. One is, am I loud and clear? I want you to respond, please.
Yeah, Doctor.
Yes, Doctor.
Okay, thank you. So that's how I get how many of you are listening. Okay. And the second is, I want to know what is HTTPS. So either you open your mic or either you type in the chat. What is the difference between HTTP and HTTPS? Yes, what is the difference? Can anyone help me, please? You can just type as well if you want, or you can just open your mic and just tell the basic difference. Yes. So basically, here we are using some encryption and verification. So that's how it's become secure. Okay. So unless otherwise protected, the HTTP request and the response sent as a clear text. So anyone with the access to the network that message travel over can potentially intercept our traffic and read without any hindrance. And you can check this using your Wireshark experiment. So since the web is used for transferring quite a lot of sensitive data, solutions have been created for preventing eavesdrop, the droppers from reading the traffic. So even if they are able to intercept it, the solutions for the most part employ some form of encryption. So a standard method for encrypting HTTP traffic is called HTTP secure or HTTPS. It uses encryption mechanism called TLS/SSL. So, and it is applied to the TCP, transmission control protocol, connection on which the HTTP traffic travels. So HTTPS typically uses TCP port 443 as opposed by the default HTTP port 80. The most user, this process is almost transparent. In principle, we only need to change the HTTP in a URL and HTTPS. Since URL lib supports HTTPS, The same is true for the Python clients. So in the Python clients, instead of using HTTP, we can use HTTPS as well. Note that not all servers support HTTPS, so simply changing the URL scheme to HTTPS isn't guaranteed to work for all sites. If this is the case, then the connection attempt may fail in a number of ways, including a socket timeout, connection reset error, or possibly even an HTTP error, such as 800 range errors or 500 range error. We have gone through all these errors. So an increasing number of sites are enabling HTTPS. However, many other are switching to a bit using as it's their default protocol. So it's worth investigating whether it's available, so you give an application extra security. Now we are moving to the request library. So that's it for the URL lib package. We did a lot of time on this, but it was honestly, it's a very good package. Too much you can do with this. So as you can see that access to the standard library is more than adequate most HTTP tasks. So we haven't touched upon all of these capabilities. There are numerous handlers classes which haven't discussed, plus the opener interface is extensible. So however, the API isn't the most elegant. So, and there have been several attempts to make improve. One of these is very popular third-party library called requests. So this request, the put top up on the previous URL lib package. So it's available as the request package on file py. It can either be installed using pip or be downloaded from docs.python-request.org, so which hosts the documentation. So request library automates the simplifies many of these tasks that we have been looking at. So the quickest way is to illustrate this by trying some examples. So the command for retrieving a URL with request is similar to retrieving a URL with URL lib package. So it is similar as we did in previous. So import requests. Now we are using a Python interpreter for that, just to remind you that these three arrows. So then response is equal to response.get, and in the bracket we put the URL. So, and we can look at properties of the response object and try. So response.status underscore code. So we get the code. You see it looks very similar with what we did with the URL lib package. Then we type response.reason. So that says okay, response.url, we get the URL. Response.headers, we are just looking for content type, so we just see the content type, but we can change the different queries for the header. So note that header name in the preceding command in the lowercase, the keys in the header attribute for request response object are case sensitive, right? So these are case sensitive. If you put the text as a capital, you will not get the similar response. So there are some convenience attributes that have been added to the response object. Response.ok is true. So the OK attribute indicates that the request was successful. That is, the request contained a status code of 200 range also. Response is redirected. That is false. It means that you were not redirected. So you can relate with the previous, the URL lib package. We did with similar things with that package. So the is direct attribute indicate whether the request was rejected. We can also access the request properties through the object response.request.headers. So you get the user agent Python request / whatever, the version, C Python, Linux, and all these things, and accept encoding, gzip, deflate, accept, and this. So notice that request is automatically handling compression for us. So you see this request package is managing the the compression by itself. So handling compression for us, and it's include the gzip and deflate in an accept encoding header. So this is the request header we sent. So if we look at the content encoding response, then we will see that response was in fact gzip compressed and request transparently decompressed for it. So response.headers content encoding, we get the gzip. So we can look at the response content in many more ways to get same byte object as we got from the HTTP response object. So perform the following. So response.content, we get this content in the byte. We did this practice with the URL lib package. But requests, whenever it's requests with the capital, you must keep in mind that we are talking about the third party, the module or the package provided in the Python. So, but requests also perform automatic decoding for us to get the decoding content. To this, we just write response.text and we will get this in the response. So notice that this is now string, is str rather than the bytes. In the previous example, here it's written in byte, but here it's written as a string. So the request library uses value in the headers for choosing a character set and decoding the content to the Unicode for us. And if it can't get a character set from the header, then uses the character, the charded library, which is called this available on this, and to make an estimate from the content itself. So we can see that encoding request has chosen here. So response.encoding, we get ISO 8859-1. We can even ask it to change encoding use. So response encoding UTF-08. Sorry, UTF-8. So after changing the encoding, subsequent references to the text attribute for the response will return the content decoded by using the new coding setting. So previously this response, so we can set the encoding to UTF. So the request library automatically handle cookies. You remember we discussed the cookies in the URL lib as well. So give the following try. So just give response get, request get, and print response cookies. So you get the class, response cookies, request jar, cookie logged in, all these things. So you remember for the previous one, we had to create jar and then we get these cookies. So it already handling. So the request library also has session class, which allows the reuse of cookies. And this is similar to using HTTP module cookie jar and URL lib modules HTTP cookie handle object. So to do the following, we reuse the s is equal to request.session s.get, and we will put Google, and response we get, the Google references. So the session object has the same interface as the request module. So we use get method in the same way as we use the request.get method. Now any cookies encountered are stored in the session object, and they will be sent with the corresponding request when we use the get method in the future. So I just keep reminding you that this is another module or package which is third party called requests, and request is somehow advanced to the package we used in the previous class URL lib. So redirects are also automatically followed in the same way. So you remember we did the redirect in the URL lib as well. So and any redirect request are captured in the history attributes. So the different HTTP methods are easily accessible and their own response. So response request.head Google. So response dot status underscore code is 200, respond.text, empty text. So we just discussed that head provides nothing. So custom headers are added to the request in a similar way as we are using URL lib. So now in this package request, we can add the headers. The user agent Mozilla Firefox 24 response request, and making request with the query string straightforward process. So prompts, we can put search term, are you going to quit? Are you sure this is a cheese shop? So we just get our response in response.url, so we can see the URL. So you see how it encoded the text as well for the specific query search. So the request library takes care of all encoding and formatting. You see this adding the plus signs, removing the space, right? So posting is similarly simplified, although we use the data keyword argument here. Data is equal to p comma Python response request post, and we can use this. So handling error with the request. So errors in the request are handled slightly different from we handle in the URL lib. So let's work through some error encoding and see how it works. So generate our 404 error by doing the following. So response is equal to request.get, and we provide this URL input, and response dot status underscore code is 404. In this situation, URL lib would have raised an exception, but notice that request does not. The request library can check the status code and raise corresponding exception, but we have to ask it to do so. Okay, so it did not create the exceptions. So response dot raise for status. So request dot exception dot http error 404 client error, right? So when we specifically ask raise for the status, so then it. So now try if it on a successful request. So r is equal to request dot get, and this is a successful URL. So r dot status underscore is 200, r dot raise for the status none. So here you see no exception, so nothing we receive. It does not do anything, which is in most situation would let our program exit a try except block, then continue we would want to it. So what happens if we get an error that is lower in the protocol stack? Like suppose r is equal to request.get, and this is, you remember we just provided one IP which is not existing. So request.exception connection error, and we get this response. So we have made a request for a host that does not exist, and once it is timed out, we get connection error exception. So the request library simply reduces the workload, and it involved in using HTTP in Python as capture to URL lib. So unless you have a requirement for using URL lib, I would always recommend using request for projects. Okay, so that is the summary. So we looked at the principles of HTTP protocol. We saw how to perform numerous fundamental tasks with the standard library URL lib and the third-party request package. So we looked the structure of HTTP messages, HTTP status code, different headers that we may encounter in request and response, and how to interpret them and use them for customized our request. We looked at URLs are formed and manipulated to construct them, and we saw how to handle cookies and redirects, and how to handle errors might occur, and how to use HTTP connections. We also cover to submit data website in the manner of submitting a form on a web page, how to extract parameters, and we need forms from a page source code. Finally, we looked at the third-party request package. We saw that as compared with the URL lib package and request automate this and simplifies many of these tasks that we may routinely need to carry out with the HTTP. This makes a great choice for day-to-day HTTP work. So in the next chapter, which we will start today, we will be employing what we have learned here to carry out detailed interaction with the different web services, query APIs for data, and uploading our own objects to the web. Okay, so here we take a break and we take a 20-minute break, and then we will start after the break.